Hi, this is Servi aka 31.1 and I would like to welcome you again to our new channel, No Problem Only Solution. And for those who are new to our channel, don't forget to hit the subscribe button as well as the notification bell so that you will get notified whenever we have video content that we will be uploading in the future. Also, don't forget to leave a message in our comment section so that I could have some time to read them and I could decide which video content I'll be creating in the future. This is a one big time help for everybody as you shape your future on becoming a professional teacher. Thank you very much and see you soon in the incoming videos. Hi and welcome back to our channel. In today's video, we'll continue our series on the proof of the trigonometric functions, and this time we are on the third theorem about trigonometric functions. And it says, if the function of x is equal to tangent of x, then the derivative of x is equal to secant squared x. So the proof of this theorem is somewhat simple compared to the previous one that we did for sine function and cosine function, because the first step that we should do is to rewrite our function tangent x into the difference of or the quotient of sine x over cosine x, because in trigonometry, as you could recall, tangent of an angle is equal to the sine of an angle over cosine of an angle. So in our case here, the given function is tangent x and our angle is x, so I am permitted to rewrite this tangent x into sine over x over cosine of x, and then the derivative of that would be equal to the quotient rule. And the quotient rule says low d high. If you could still remember the shortcut in your module, we have the denominator times the derivative of the numerator, in short, that is low d high, minus high d low, or the numerator times the derivative of the denominator all over low squared, or you will square the denominator. So applying quotient rule now to our function sine over x over cosine of x, this will be equal to the denominator, which is cosine x, times the derivative of the numerator, which is previously we know that the derivative of sine x is cosine x, minus the numerator sine x times the derivative of the denominator, which is negative sine of x, because the derivative of cosine x is sine of x, all over cosine of x squared. Okay, and now cosine of x times cosine of x is equal to cosine of x squared minus sine of x times negative sine of x, that will be equal to positive sine of x squared, all over cosine of x squared. And at this point, we need to rewrite our function in a more compact form, and we know in trigonometry that cosine x squared could be written as cosine squared x. That is the same thing, plus sine squared x all over cosine of cosine squared x. Okay, that is the product of cosine x times cosine of x. And in trigonometry also, we know that the numerator here, which is this one, cosine squared x plus sine squared x, this is an equivalent value for Pythagorean identity. Okay, so I will write here Pythagorean identity. You must review your trigonometry because this whole thing is equivalent to 1. Okay, if in trigonometry we represented this one as x squared and this one is y squared, which is equal to 1. So in that case, I will be permitted to rewrite my numerator as 1 because of that Pythagorean identity in trigonometry. So the result will be 1 over cosine squared x. And this is a reciprocal function because we have a numerator of 1. So the reciprocal of cosine, we know that the reciprocal of cosine is secant. So I could rewrite this one as secant squared x over 1, or the final answer, secant squared x. And this is now our derivative for tangent of x. So we have arrived at this answer, secant squared x, which is the derivative of tangent x. So finally, if someone would ask you what is the reason behind why the derivative of tangent of x is secant squared x, then this is the whole process, and that's it. Thank you very much, and see you soon in the next video.